Okay, hello, Math 2. This is your first screencast, and before I begin, I want to make sure that you understand what you need to do when you have a screencast, okay? When you have a screencast, you want to make sure that you are taking notes from the screencast just as you would in class. And so, because this is your first one for me, I want to make sure that the expectations are clear. But every once in a while, I'm thinking maybe once a month or so, you'll have a screencast that accompanies your homework. And when that happens, you want to watch the screencast first, take the notes, and then do the homework that follows. And it's all on the teacher page there, as you can see. In this screencast, we're going to do two things. We're going to talk about, or I should say, continue talking about our question number 107. And if you'll remember, this was the handout that I gave you in class, and it was just this one question written on it. And I think we left off with finding the area of PQRS. And we were talking about in class what the shortcut would be. You should all have this in your notes, so please go and find those. And we were just kind of coming up with ideas when the period ran out. So I want to make sure that we do leave with that shortcut, because I know you love shortcuts. And then we're going to talk about a little bit about something called number of outcomes and something called a sample space, given certain combinations of different variables. But first things first. So let's go here, and you'll remember, I believe it was Haley and Ben, I think it was, that brought us to the point where they knew that if the coordinates of Q were A comma B and S the ordered pair, or C comma D, Ben and Haley, I think they both thought they did it differently, but in the end, they really did it the same way. We see the coordinates of point R are A plus C comma B plus D, okay? So, and again, because this question, it's just giving you variables, what these ordered pairs would be, no matter what these numbers are, A, B, C, and D, we know that this point R here is the result of the X coordinates added and the Y coordinates added to get your X and Y coordinates of the point R. Okay, so then we were talking about the area of the parallelogram. And I think I'm going to blow up here for a second and make sure your drawing is nice and clear. I think you'd all agree that if we were going to find the area of this parallelogram, kind of quote unquote, the easy way, we'd have to figure out what the altitude or the height of the trapezoid is, and the altitude or the height is that segment that is perpendicular to both bases of the parallelogram, right? We have to find that altitude, and then we'd have to find the length of a base of a parallelogram and then multiply them, right? Now, the length of this base right here, we would use the distance formula. But I think you'd agree to find this altitude, it would be a big old mess, because let's talk it through. This is kind of similar to all those distance questions we were doing. Because to find this altitude, we'd have to find the equation of the line perpendicular to this base, which would involve finding the slope of segment PQ, taking its opposite reciprocal to be the slope of the altitude. And then we'd probably use this point, a point on this altitude line, so to speak. And then we have to solve a system of equations, right, to find the point. And then distance formula to find the altitude, all to get us to the area of the parallelogram, which is just base times altitude. I think you'd agree. In fact, I can already hear you groaning, because even when I say take away their calculators, you all react like I'm saying, take a fork and let's poke it in your eyeball. It's like, so I'm sure this is eliciting groans of pain from you all. So the question I had for you was, is there a shortcut? And I think I recall Max going up to the board and doing something, and someone else going to the board and doing something. And I'm going to put up a drawing here, and I don't remember who this was that drew this, but I'm going to basically make a rectangle. But here's how I'm going to make the rectangle, everyone. I'm going to drop, okay, an altitude there. And I'm going to drop I shouldn't say altitude, I dropped a vertical line and a horizontal line, okay? Now, what I have here is, with this vertical and this horizontal line, I think you now see that if I then use the coordinate axes, I have a rectangle. Now here's where you're going to start getting involved in this. I'm going to go over here and do the following. I'm going to create these little rectangles right here. Okay, and here's a rectangle right here. All right, everybody, this is where the thinking begins for you. All right, it's a rectangle right here and a rectangle right there. And the reason why I'm saying rectangle is even though I look at my drawing and it looks square-like, right? I can't assume that it's a square, right? I don't know what the values A, B, C, D are. All right, everybody, by yourself or with your, reflection in the mirror or with your puppy or with, if you happen to have a classmate with you, what I'd like you to do is generate an expression that would describe the area of these pink squares here. And I want your expression to involve the variables A, B, C, and or D, okay? And then replay me for the answer. Well, let's see. I'm going to do some thinking to myself here. And I see that if this is the point AB, that means this distance is A, right? And of course, this distance here has to be C, because the entire distance is, look at this, let's drop it down here. The entire distance here is A plus C. That means for this little rectangle here, I know that one dimension is C, right? So the area of this little pink rectangle is C times, now the question becomes, what is this distance, everyone? What would that distance be right here? That distance, what do you think? Well, that distance is just going to be B. So that this pink square right here has an area of C times B, or I'm going to write this alphabetically, B times C. That's the area of that lower rectangle. Do you see that? All right. Well, this pink triangle here, what do you think, everyone? This distance is, right here, this distance is what? C, right? What's this distance? That distance has to be, well, let's see. What's this distance right there? What is that distance? That distance is D, agreed? And because we know, look at that, if B plus D is the vertical distance up from R, that means B plus D has to also be here. This is B plus D. That means this distance here is just B. So the area of this pink rectangle, that area is B times C. Okay, so let's go down here and make a little note to myself. The two pink rectangles areas are BC plus BC, or just 2BC. All right, everybody, now what I want you to do is I would like you to go and find the area of this triangle right here. Look what I'm highlighting, that triangle, and this triangle. And what I'd like you to do is, here I'm going to let you go on your own. Find the area of those two triangles and then replay me for the answer. Well, I'm going to change up my color here. And here's where I personally think it's just so fun to do all this stuff. I'm going to erase here as I work this through. Just to make room for myself here. Okay. Lovely. All right. So I'm going to go over here and have a conversation with my reflection in the mirror. This triangle I know is 1/2 base times height, but I know that that area is 1/2 times, because this is a 90-degree angle, right? I know the base here is C times, and then what's this distance here again? Oh, I have it labeled right there. It's 1/2 times C times D. That's the area of that yellow triangle. I'm really close to just being able to say, wouldn't this also just be 1/2 times C times D? I'm just going to make doubly sure. Well, I know that this length right here, right, which is this length, does in fact equal C. And I know that this length here is definitely D. So yes, that is the area of the triangle. So then the two yellow triangles areas is going to be 1/2 C times D plus 1/2 C times D. These are like terms, so I get 1 CD, or just C times D, right? All right, I think you know where I'm going now. Please find the area of that triangle and this triangle down here. Okay, and I think we can look and we can see that those are going to be the same areas. Okay, and I'm going to come down here and do this. Let's see. All right, this triangle is area equals, once again, I know it's a 90-degree angle right here, 1/2 base times height. Base times height. What's the base? 1/2 times base times, what's the height here, everyone? That height, this here, is B. 1/2 A times B. And I know that this triangle will also have an area of 1/2 times A times B. So the two blue triangles areas are 1/2 A times B plus 1/2 AB, which equals just 1 AB, or just AB. Okay, now let's back it up. So I know you're thinking, wait, she told us it's going to be a shortcut. This does not seem very short. But you know what, boys and girls, I think it's shorter than the long cut. And the long cut, oh my goodness, finding the equation of the perpendicular line, finding the point of intersection to solve a system, then using distance formula. So now what I'm going to do is do this. The area of the parallelogram, which is the question all along, right? This, after all, was the area we want. Why don't we just find the area of this entire rectangle and then do what, everyone? Yes, subtract out all of these, and that will leave you with the area of the parallelogram. So I am going to say, at the end of the day, granted, it may not have been the most delightful thing to do, but the area of the parallelogram is equal to base times height. Okay, so I'm going to go back and draw. What is this length here? Or length times width. That length is A plus C, right? So it's A plus C times the height right here. What is this height? That is B plus D. A plus C times B plus D. That's the area of the entire rectangle. Then I want to subtract out each of these. Minus 2BC plus CD plus AB. And what we get at the end of the day, and I'm going to actually practice this. Let's just go ahead and multiply this out, okay? I get, and I know you're all saying FOIL, AB plus AD plus BC plus CD minus, don't forget this negative, you have to distribute it, right? Minus 2BC minus CD minus AB. This is the area of that parallelogram. Now, everyone, do you see anything here? I hope you do. Do you see any terms that cancel? See how fun this is? Positive AB, negative AB, gone. Positive CD, negative CD, gone. Positive BC, negative 2BC, that leaves you with negative 1 BC plus AD. Or I like to just write this a little bit more neatly with the negative second, AD minus BC. So look at that shortcut. It's a beautiful thing. It's a beautiful thing. This is what I would like to make sure I definitely go and box and square and be really, be really excited about. If you have what am I doing? What is Missy M doing? If you have an area, if you have a parallelogram and you know that the parallelogram is set up so that you know the ordered pair, okay, of any two sides. So let's say I know that a parallelogram has these two segments where this point is 8, 2, and this point here is 4, 11, right? And don't forget, this is a case where this is A, B, and C, D, right? Because that's how it's set up, right? That's how it's set up. So, because all our generalization, this whole shortcut came about with the understanding that the point A, B, and C, D are right there. But now, look what you've got. If you have this beautiful rule right here, right? And you know that this AD and BC come from the ordered pair of these parallelograms, guess what? If you're asked to find the area of a parallelogram whose adjacent sides are formed by these line segments, all you have to do is say that the area of this parallelogram with these two sides is going to be A times D. What's A times D? Yes, it is 8 times 11 minus B times C, 2 times 4, which equals 88 minus 8, which equals 80. Okay? I can see a lot of questions about this. I'm going to give you a little hint here. I know that one of the questions on homework asks you to, I think the setup is like this. It says, given two line segments, like these two right here, find the area of this triangle, right? Well, again, you have the long way to do this, which is, again, figure out the altitude, right? It's long and long and long. But now you know the area of this triangle is just going to be half of the area of the parallelogram. So I just gave you a little bit of a hint. All right. So this is really, really lovely. And I can only imagine the party that you are throwing in your head right now, because you're saying to yourself, wait, Miss Yam never gives us shortcuts. And here she gave us a shortcut, right? Which is awesome. Okay, so I'm going to save the outcomes and I think sample space stuff for another class. But this is the screencast that accompanies this homework, and I hope you enjoyed it. Bye, everyone.